Hello students, this video is continuation to the previous video, which is the introduction to the limit topic. There we have discussed the definition of the limit of a function. We have discussed how do we calculate the neighborhood of a point, and we find that the neighborhood of a point is basically a circle. Apart from this, we have discussed how do we calculate the distance between the 2 points and how to establish the problem based on the limit of a function using delta epsilon approach. So in this video, we'll discuss the problem based on the concept of limit and continuity of the multivariable function. So let us start with, firstly, in the last video, we have discussed the definition of the limit of a function, that limit xy approaches to x naught y naught f of xy equal to L. What is the meaning of this particular expression? It means that if we consider a very small number, say epsilon, which is very small number, then there exists a real number delta, which is again a very small number, such that the difference between these two numbers is less than a very small number whenever x minus x naught square plus y minus y naught square its root is less than delta. That means whenever we choose a point in the neighborhood of a point x naught y naught, rather a deleted neighborhood of a point, because while solving the problem of the limit of the function, we find that it is not necessary that your function is always defined at the point x naught y naught, right? So there also we realize that the neighborhood of a point is basically a circle, because if I scaling both sides, then we get equation as x minus x naught square plus y minus y naught square is less than delta square. It simply represents the equation of a circle whose center is at the point x naught y naught and radius is delta. So basically we are considering all the point inside this circle whose center is at the point x naught y naught, right? Okay, but now in this particular part, we'll try to discuss some problem based on the limit of the function. So let us start with. So the first type of the problem is when, because if we talk about the different type of the problem based on the limit of a function, so we can categorize it into two or three different type of the problem. The first type is when your function f of xy is defined at the point x naught y naught. Okay, so the type of the problem, if we consider here, suppose we are considering example number one, where the example number one is the question is limit xy approaches to the point x1 and minus 1, and this is your function here. Your function is x square minus xy plus y square upon x minus y, right? So this is your function. Now, in this particular case, we know that when the function is in the rational form, so first step is we want to check that either your function is defined. Defined means that your denominator should be non-zero. So if I substitute x equal to 1 and y equal to minus 1, so we find that x minus y, its value is 2, which is definitely not equal to 0. So because this denominator is non-zero, it means your function is defined at the point 1 and minus 1. So in this case, the limit of the function is obtained by simply replacing x equal to 1 and y equal to minus 1 in this function. So here we have replaced x with 1 and y with minus 1. Then we find that the limit of the function comes out to be 3 by 2. Okay. Now let us consider another problem. So here the another problem is limit xy approaches to 1 and your function is x square plus y square upon x plus y minus 1. This is your function. This is the limit problem, right? Now in this case again, it is a rational form of the function, and here your denominator is x plus y minus 1. So if we substitute the value of x as 2 and y as 1, then 2 plus 1 is 3, 3 minus 1. Even if we cancel out 1 with 1, we left with 2. That means your denominator is non-zero. So because your denominator is non-zero, so it means your function is defined at the point 2, 1. So the limit of the function can be obtained by replacing x equal to 2 and y equal to 1. So we can get the limit of the function as 5 by 2. Okay. Now let us consider another problem here. This is the problem number 3. So here your problem is limit xy approaches to 0, 0, and your function is x plus y upon x square plus y square plus 1. So this is the limit problem. Now again, it is a rational form of the function where your numerator and denominator both are polynomial function. So again, if I substitute x equal to 0 and y equal to 0 in the denominator, then if I replace x equal to 0 and y equal to 0, then its value is 0 plus 0 plus 1. Of course, your denominator is non-zero because of the presence of this constant term. So it means your function is defined at this point. So because your function is defined at the point 0, 0, so the limit of the function is obtained by replacing x equal to 0 and y equal to 0. So hence we can get the limit of the function as 0 only. Okay. So these are some type of the problem where the function is directly defined at the point x naught y naught. So in that case, the limit of the function is obtained by simply replacing x equal to x naught and y equal to y naught. Okay, now come to another type of the problem. The another type of the problem is when your function is not defined at the point x naught y naught, but the limit of the function exists. Okay, so how do we identify such kind of problem? So in this case, we are considering two different cases. Case number one is if your function f of xy can be expressed as a product of the two function, where one function depend upon variable x only and the another function depend upon variable y only. Okay, and where the limit of this individual function exists. Okay, so what does that mean? Suppose that the limit x tends to x naught g of x exists and the limit of this function is say L1, right? And the limit of y approaches to y naught hy also exists and let's say it is equal to L2. So if the limit of this function exists, so now we'll try to calculate the limit of the function at the point x naught y naught. So how do we solve this particular problem? So firstly, we'll try to split this function as a product of two functions where one function depend upon x only and another function depend upon y only. And then we apply the limit to the product of two function as a product of their limit. But because this function depend upon x only, so it means that there is no role of variable y here. So this limit treat like a limit of single variable, like limit x tends to x naught g of x. And here limit xy approaches to x naught y naught hy become limit y tends to y naught h of y. Now because the limit of the function this one exists and this limit is equal to L1 and this limit is L2. So it means that the limit of the function f of xy is equal to L1 into L2. Okay. Now to understand this concept, let us consider one example here. Suppose we are considering one problem here. The question is, suppose that we are considering a problem limit xy approaches to 1, 0 and your function is x minus 1 into sine y upon y into log of x. Okay, so we want to evaluate the limit of this function. Now here you find that all the terms are in the product form, x minus 1 into sine y, y into log x. Again, it is a rational function, but now in this case, if I put y equal to 0 here, because x approaches to 1, x, y approaches to 1, 0, means if I put x equal to 1 and y equal to 0, then y is 0 means your denominator is 0. Okay, so it means that your denominator is 0. Denominator is 0 means your function is not defined. And but after substituting its value in the denominator, if your denominator is 0, then we'll check that what is the nature of the numerator function. Because if your denominator tends to 0 and your numerator is non-zero, in that case, the limit of the function does not exist. Okay. But here we find that if I put x equal to 1 in the numerator, then 1 minus 1 is also 0. So basically it is 0.0 form. It is 0.0 form. So when it is 0.0 form, in that case, limit of the function may exist. Okay. So first step is, because we find that all the terms are in the product form. So firstly, we'll try to split this function as limit xy approaches to 1, 0. I'll try to express this function as x minus 1 upon log x into sine y upon y, right? Now you can see here, this function depend upon x only, and this function depend upon y only. So in this case, if we apply this limit, then this limit can be expressed as limit x tends to 1 x minus 1 upon log x, because this function depend upon x only, so there is no role of y. And similarly, this can be written as limit y approaches to 0 sine y upon y, because in this particular part there is no role of x. So it behave like a limit of single variable function only. Okay. Now in case of single variable function, if we again, if I put x equal to 1, this is 0.0 form, 0.0 form. So in that case, we can use L'Hopital rule. We can use L'Hopital rule. What it state that limit x tends to x naught f of x upon g of x. If we have a rational form of the function and f of x naught is equal to 0, g of x naught is also equal to 0, then this limit is equal to f dash x naught upon g dash x naught, provided g dash x naught is not equal to 0. Provided g dash x naught is not equal to 0. Okay. And even if your first order derivative is again gives us 0.0 form, then we can further extend it to the higher order derivative also, right? Basically, this concept come out from the Taylor theorem result only. The condition is your function should be continuously differentiable up to order n. In that case, we can use this concept up to nth order derivative also. Okay. But now, if we are using this concept here, so let us suppose I try to calculate the limit of this part. So what about limit x tends to 1, x minus 1 upon log x? Now, because in this case it is 0.0 form, so what can we do? We can differentiate numerator function and denominator function. So what is the derivative of x minus 1? So the derivative of x minus 1, derivative of x is 1, derivative of 1 is 0, so its value is 1. And what about the derivative of log x? Derivative of log x is 1 upon x. So it means that it becomes 1 upon x, right? Now, if I put x equal to 1, your function is defined at that point. So we can get the limit of the function as 1 upon 1. Hence, the limit of this function is 1 only. Okay, so what does it mean? The limit of this function exists and is equal to 1. Now we'll calculate the limit of the second function, that is limit y tends to 0 sine y upon y. Although it is an identity that limit x tends to 0, this is an identity that limit x tends to 0 sine x upon x is equal to 1. But otherwise, we can see here it is 0.0 form. So again, here we can apply L'Hopital rule also. So what is the derivative of sine y? The derivative of sine y with respect to y is cos y, is equal to cos y. And derivative of y with respect to y is 1. So it means that this is equal to cos y upon 1. Now the function is defined at the point y equal to 0. So in this case, the limit of the function is cos 0, and cos 0 is equal to 1. So what do we find out here? The limit of this particular function is 1, and the limit of this function is also equal to 1. So what is the limit of their product? This is equal to 1 into 1. Hence, the limit of this function is 1. So what is the limit of this function? The limit of this function is 1. Okay, so what do we find out here? Here in this case, your function is not defined at the point x naught, y naught, but your function can be expressed as a product of two functions, where one function depend upon x only, other function depend upon y only. So we can split this limit as a product of two limit, that is the limit of function of x, limit of function of y. And if it is 0.0 form, that is if it is indeterminate form, then we can apply L'Hopital rule, like we can adopt the same procedure which we can use for the indeterminate form for variable function, and we can calculate the limit of the function easily. Okay, now let us consider another problem here to understand this concept. Let us consider example 2. Suppose that we have a function limit xy approaches to 0, 1, and your function is y minus 1 into tan square x upon x square into y square minus 1. Okay, now again it is a rational form of the function, and in the denominator we have a polynomial function only. So the first step is we want to check that either your function is defined at the point x naught, y naught. So I simply put x equal to 0. If I put x equal to 0, your denominator is 0. If I put y equal to 1, even 0 and 0, it is 0 only. So your denominator is 0. Now the next step is we want to check what about the numerator. If I put y equal to 1, 1 minus 1 is 0, and tan 0 is also 0. So basically it is 0.0 form. So it is 0.0 form means the limit of the function may or may not exist, right? So now we move on to that next step. So next step is, here we have seen that all the terms are in the product form, right? So because all the terms are in the product form, so we will try to express it as a product of two function. So we can write it as limit xy approaches to 0, 1. So if we extract the function of x alone, then we have a term tan square x upon x square, and we have another terms y minus 1 and y square minus 1. So now you can see here, this is the function which depend upon x only, this is a function which depend upon y only. So we can rewrite this limit as a product of two limit x tends to 0, this is basically tan x upon x whole square, and this is limit y approaches to 1, y minus 1 upon y square minus 1. Okay, now again it is 0.0 form and 0.0 form here. So when it is 0.0 form, so we'll try to either apply L'Hopital rule or we'll try to find out some other method to solve this particular equation. So we have again one of the identity that limit x tends to 0, tan x upon x, this also limit is equal to 1, right? So either we can use this result directly, otherwise to solve this particular part, because it is 0.0 form, so we can apply L'Hopital rule also, right? Or in other way I can write limit x tends to 0, this is tan square x on x square. Now because it is 0.0 form, so because it is 0.0 form, so what can we do? We can apply L'Hopital rule. So differentiate numerator function. So what is the derivative of tan square x? Now because it is a composition of the two function, okay, tan square x. So the derivative of tan square x is 2 times tan x into secant square x. And in the denominator, we have a x square. Derivative of x square is 2x. Okay. So we know that what is the derivative of tan square x. Now because it is a composition of the two function, the first function we need to apply power rule. Okay, square. So derivative of x square is 2x. So here x is tan x because I want to differentiate it with respect to x only. So we use the concept of derivative composition of a function. So we get the derivative of tan square x 2 times tan x, and derivative of tan x is secant square x, secant square x. And the another function is x square. So derivative of x square is 2x. Okay. So this is the first step. You can see here 2 and 2 get cancelled out. Still, if I substitute x equal to 0, tan 0 is 0 and 0. So again it is 0 0.0 form. So again if it is 0 0.0 form, then again we can apply L'Hopital rule. But this time we have a product of the two function in the numerator. One is tan x, another one is secant square x. So we apply here product rule. So what is the derivative of the product of the two function? Derivative of the product of the two function is first function derivative of second plus second function derivative of first, right? So we can use this particular formula. So this is your u and this is your v. Okay, and again it is a composition of the function. What is the derivative of tan x? Derivative of tan x is secant square x, and derivative of secant x is secant x into tan x. Okay, and derivative of x square is already 2x. So basically it is a composition of the two functions. Secant square x means it is a composition of two functions. One is x square, another one is secant x, right? So when we differentiate x square, then its derivative is 2x. And when we differentiate secant x, its derivative is secant x tan x, right? So if we apply this formula, so what do we get? U, that is tan x, derivative of secant square x is 2 times secant x into derivative secant x is secant x into tan x. So it is secant x into tan x plus secant square x as it is. Derivative of tan x is secant square x divided by derivative of x is 1. Now you can see here your denominator is 1, which is non-zero. So your limit is defined at the point x equal to 0. So what is the limit of the function now? So if I put x equal to 0, tan 0 is 0 into 2 times secant square 0 into tan 0. And this is secant raised to the power 4 times 0 upon 1. Now we know that tan 0 is 0 because tan is the ratio of sine and cos. Sine 0 is 0, cos 0 is 1. So tan 0 is 0. And secant 0 is 1 because secant is the reciprocal of sine function. It is 1 upon cos 0. And cos 0 is 1. So its value is 1 only. Secant 0 is 1, tan 0 is 0. So its limit comes out to be 0 plus 1. So limit is 1 only. Okay, so it means that the limit of the first function is 1. Now what about the second one? Now we consider limit y approaches to 1, y minus 1 upon y square minus 1. Although it is 0 upon 0 form, so I can solve it in two ways. Either we can apply L'Hopital rule. So L'Hopital rule means because it is 0 upon 0 form, so its derivative is 1, its derivative is 2y. So now if I put y equal to 1, then its limit is 1 upon 2 because now your function is defined. Or on the other hand, we can also solve it in this way, that this can be written as limit y approaches to 1. This is y minus 1. Now this function can be factorized as the product of two linear factor y minus 1 and y plus 1. Now because y approaches to 1, y approaches to 1 means y is very close to 1, but it is not necessarily equal to 1. So it means that we can cancel out these two factors. And now Because your function is defined, if I substitute y equal to 1, then its limit comes out to be 1 by 2. So either we can apply L'Hopital rule or we can use the concept of limit here. So in any way, you can find out the limit of this function is 1 by 2. So therefore, so what is the limit of the given function? So therefore, limit xy approaches to 0, 1, your function is y minus 1 into tan square x, y minus 1 into tan square x upon x square into y square minus 1, which is equal to limit x approaches to 0, tan square x upon x square into limit y approaches to 1, y minus 1 upon y square minus 1. So the limit of this part is 1 and the limit of this part is 1 by 2. So the net limit of this function is 1 by 2 only. So this is the limit of the function. Okay, so it means that this is the case when your function is not defined at the point x naught y naught, but it can be expressed as a product of the two functions where the limit of the individual function exists. Okay, so this is the another type of the problem here for the limit when your function is not defined but the limit of the function exists. Now let us consider another form of the problem. Another form is when your function is not defined but the limit of the function exists. Okay, so how do we calculate the limit of the function in that case? Okay, so now we are considering, I can rather directly considering the case 3 where the limit of the function may or may not exist. Okay, like suppose I can directly consider case number 3 when f of xy is not defined at the point x naught y naught. Okay, so in that case the limit of the function may or may not exist. But one important thing you need to remember that whenever you are solving the problem of a limit, the important thing is if the limit of the function exists, if the limit of the function exists, it must be unique. It must be unique. That means if we consider any neighborhood of a point, if we consider any neighborhood of a point, if we consider any neighborhood of a point, then the value of the limit should always remain same. So it means that if the limit is a different along, if that means if we choose a different neighborhood point and the limit of the function is different, then we say that the limit of the function is does not exist. Okay, that means if the limit depend upon the path, means when for example I choose any point x naught y naught, this is in a plane x naught xy, so this is your plane xy, x-axis, this is y-axis, and this is origin. So you can see here there are infinitely many curves which actually passes through this particular point. Maybe straight line, maybe this curve, maybe parabola. There are so many curves which actually passes through this point. So every curve containing the neighborhood of this point. So if the limit is a different along a different path, then the limit of the function does not exist. If the limit depend upon the path, depend upon the path, then the limit of the function, then the limit of the function does not exist. Function does not exist. Okay, so now we'll try to identify the cases where the limit of the function exists and where the limit of the function does not exist. Okay, So let us consider some problem to identify the same thing. So suppose we are consider a problem. Suppose we are considering an example. Example is limit xy approaches to 0 0 x upon x square plus y square, right? Now in this case, if we just look at this problem, here again if I put x equal to 0 and y equal to 0, your denominator is 0. And if I put x equal to 0 in the numerator, it is also 0. So basically it is 0 0 form. Okay. It is 0 0 form, but in this case, your variables are not separable because here we have a term x square plus y square. Okay. So whenever we have this kind of term, in that case, the limit of the function may or may not exist. Like I already told you, when it is 0 0 form, then the limit of the function may or may not exist. But now, how can we check that either the limit of the function exists or not? Like I already told you. So if the limit of the function exists, it must be unique along all the path. Okay. So what can we do to check that either the limit of the function exists or not? So the first thing is, if your function is in the polynomial form, simply check the degree of the numerator function and the degree of the denominator function. So here the degree of the numerator function is, here in the numerator the power of x is 1, but in the denominator the power of the variable is 2, that is power of x is 2, power of y is 2. So if the degree of the numerator function is less than the degree of the denominator function and it is 0 0 form, okay, so in that case the limit of the function does not exist. Then the limit of the function does not exist. Okay, so there are many different ways to prove the same. The first thing is, now if we choose, like whenever I want to prove that the limit of the function does not exist, I need to simply identify a path where the limit of the function actually does not exist. Okay, like I already told you, if the limit of the function exists, then it must be unique along all the neighborhood of a point, right? Neighborhood of a point means like there are many curves which passes through this point, and every curve contain the neighborhood of this point, right? So like in this case, if I choose the neighborhood of a point 0 0 along the curve, say y equal to mx. Okay, why? Because here the power of x is 2 and power of y is 2. So we can convert it into single variable function by choosing a path. Let us choose a path. Let us choose a path y equal to mx, because it represents a class of straight line passes through the origin, right? What is the meaning of y equal to mx? Y equal to mx means y equal to x, y equal to 2x, y equal to 3x, y equal to minus x, y equal to minus 2x. There are, it simply represent a class of straight line which passes through the origin. And every line containing the neighborhood of a point 0 0, because as x approaches to 0, y also approaches to 0. Okay. So if we choose this uh, this particular path which containing the neighborhood of a point 0 0, and now what will happen in that case, this limit. Now this limit now converted into limit x approaches to 0, because if I replace y equal to mx, then this limit now converted into limit of one variable function. So this is limit x tends to 0, x upon, sorry, here we have xy tends to 0 0. So now if I replace y equal to mx, then this is x square plus m square into x square. Now if I take x square common from the denominator, so we left with 1 plus m square. Now 1 power of x get cancelled out from the numerator and denominator. So what do we left with? So this is equal to limit x tends to 0 1 upon x into 1 plus m square. Now, because we know that limit x tends to 0, 1 upon x does not exist. It does not exist. Why? Because limit x tends to 0 from positive 1 upon x, it tends to plus infinity, because if I choose x to be a very small number but from the positive side, for example, I choose x as, say, uh, very close to 0, like I can consider 10 raised to the power minus 5, then its value is 10 raised to power 5. Okay, this is very close to 0. Even I can consider 10 raised to the power minus 10, then this value is not unique and rather it is a very large number. And on the other hand, if I consider limit x tends to 0 from negative side, then 1 upon x tends to minus infinity. So it means that limit does not exist. So because this limit does not exist, it means that limit xy approaches to 0, 0, x upon x square plus y square does not exist. Okay, so this is one of the way to solve this particular problem. There is another way where with the help of which we can solve this problem. What can we do? Like in the beginning of the definition of the limit of a function, we have discussed that the neighborhood of a point is basically a circle, right? So what can we do? We can convert this problem into polar form. Okay, so we simply assume put x equal to r cos theta, y equal to r sin theta. We simply convert this variable into polar form. So what do we get? X square plus y square is r square. So x square plus y square is r square. So as xy approaches to 0, 0, it implies that r approaches to 0. Okay, like I already told you, when xy approaches to 0, 0, it means that what is the neighborhood of a point? The neighborhood of a point is basically a circle. So if I say that this is a point 0, 0. So what is the neighborhood of a point? Neighborhood of a point is a circle. So if I can choose any point on this particular neighborhood of a point, that is on a circle. So if I say that this point xy approaches to the x 0, 0, it means that if this distance is r, it means that r approaches to 0, right? So it means that this problem now converted into limit xy approaches to 0, 0, x upon x square plus y square. Now this is equal to limit r tends to 0. What is x? This is r cos theta. And what is x square plus y square? This is r square. Now you can see here one power of r get cancelled out. So if r tends to 0, and here we have a cos theta. So cos theta can be positive, cos theta can be negative. So what do we have? We have limit r tends to 0, cos theta upon r, which tends to either plus infinity or minus infinity. Hence limit does not exist. Because the radius of a circle is always positive. So r tends to 0 from positive side only. But cos theta can be positive or cos theta can be negative. So if I multiply positive with number tends to infinity, then it gives us plus infinity value. And if we multiply a very large number with a negative sign, then it will tends to minus infinity. Okay, hence we can conclude that the limit of the function does not exist. Okay, so whenever I want to prove that the limit of the function does not exist, there are two ways. One is we can identify a path where the limit of the function does not exist. Okay, or if we find that we have a factor x square plus y square, then preferably we can convert that problem into polar form, and where we can check that either the limit of the function exists or not. Okay, basically whenever we want to prove that the limit of the function exists, we preferably convert the problem into polar form only, because we know that the neighborhood of a point is a circle. So if we say that the limit of the function is unique along all the neighborhood of a point, then we know that all the point will be covered in circle only. Okay, let us consider another problem based on this particular part only. Okay, suppose we are considering another problem on the basis of a limit of a function. The question is limit xy approaches to 0 0 x square upon x cube plus y cube. Now again, if you just look at this problem, where the degree of the numerator function is 2, degree of the numerator function is 2 and the degree of the denominator function is 3. So because the degree of numerator is less than the degree of the denominator function, right? And also it is 0, 0.0 form, because if xy approaches to 0 0, that means it is 0, 0.0 form. Okay, so how can we prove that? In that case, simply we need to prove that the limit of the function does not exist. That means we'll try to put some effort to identify a path where the limit of the function does not exist. So the simple way is, what can we do? We simply try to make your denominator function homogeneous. Already we find that here the power of x and y is same. If the power of x and y is same, we can simply choose a path y equal to mx. Let us choose a path. Let us choose a path y equal to mx. Okay. So why I'm choosing y equal to mx? Because the power of x and y is same. I'll try to substitute in such a way so that the power of the variable is same. Okay. So because as x approaches to 0, y approaches to 0. So it means that it must contain the neighborhood of a point 0 0. So your limit xy approaches to 0 0, x square upon x cube plus y cube. Now this is converted into limit x tends to 0, x square upon x cube plus this is mx whole cube. So this is limit x tends to 0, x square upon x cube is common. We have 1 plus m cube. Now 2 power of x get cancelled out. So we left with limit x tends to 0, 1 upon x into 1 plus m cube. Again, limit x tends to 0, 1 upon x does not exist. Hence, we can say that limit xy tends to 0 0, x square upon x cube plus y cube does not exist. Right? Okay. Now let us consider another problem here. So another problem we are considering. Now this is a bit different problem where we are given that limit xy approaches to 0 0, but this time we are given function as x power 4 y square upon x power 4 plus y square whole square. Now, what will happen in this case? Again, if I put x and y equal to 0, then your denominator is 0, your numerator is also 0. So it means it is 0, 0.0 form. 0, 0.0 form. Now, if we look at the power, what is the power in the numerator? So because the variables are in the product form, so their power is added. So power is 4 plus 2, 6. So degree of the numerator is 6. Degree of the numerator is 4 plus 2, that is 6. And what about degree of the denominator? Degree of the denominator is maximum power is 4 and whole square is 8. So 4 square is 8. That is 4 into 2, its power is 8. Again, degree of numerator is less than the degree of denominator. So it means that we'll try to prove that the limit of the function does not exist. Okay. So again, we need to choose a path to prove the same. So what can we do in that case? We are trying to make your denominator function homogeneous. Here the power of x is 4, but the power of y is 2. So we need to choose a path which contains the neighborhood of a point and it will make your denominator homogeneous function. So what can we do? Let us choose a path. Let us choose a path. What can we do? I can put y equal to mx square. Basically, I want to make the same power. So there are two ways. Either I can choose x square equal to y. So if I choose x square equal to y, then automatically x power 4 become y square. So y square becomes same. Okay. So we need to make your denominator. Basically, I want to reduce your denominator function into the homogeneous function so that the degree of the denominator term are same. And because it is a kind of parabola, upward or downward parabola, depend upon either m is positive or negative, right? So what do we find out here? As x approaches to 0, y also approaches to 0. That means it also contains the neighborhood of a point because it represents a class of a upward or downward parabola whose vertex is origin, right? So we can choose different parabola whose vertex is origin only, right? So if I choose in this way, then what do we get? So we can get limit xy approaches to 0, 0, x power 4 y square upon x power 4 plus y square whole square. This can be written as limit x approaches to 0 because when I replace y equal to mx square, it means that now y will be vanished. So we're left with x only. So in the numerator, we have x power 4. And what is your y? It is mx square. So mx square whole square. And in the denominator, we have x power 4. And here we have mx square whole square. And its power 2. So this is limit x tends to 0. So here m square is constant taken outside. X power 4 into x power 4. And in the denominator, x power 4 plus m square x power 4 and its whole square. So limit x tends to 0, m square x power 8 and here x power 4 whole square common and we left with 1 plus m square whole square in the denominator. So x power 4 whole square means x power 8. So you can see here this x power 8 and x power 8 get cancelled out. So what we left with? We left with limit x tends to 0 m square upon 1 plus m square whole square. So because it doesn't depend upon x, so what is the limit? M square upon 1 plus m square whole square. But what is m? Here m is any arbitrary number because I can choose a class of a parabola whose vertex is a region. So here m can be positive, m can be negative, m can assume any value. So because m is arbitrary and corresponding to different value of m, we get a different limit. So because limit depend upon m, and I told you if the limit depend upon path, it means that limit does not exist, right? So because limit depend upon m, but m is arbitrary, hence limit does not exist. But m is arbitrary, hence limit xy approaches to 0, 0, x power 4 y square upon x power 4 plus y square whole square does not exist. Okay, so these are the cases we have discussed that where the limit of the function does not exist. So what are the different way you can identify that where the limit of the function does not exist? When the degree of the numerator is smaller than the degree of denominator. Okay, but it is not necessary that if the degree of numerator is greater than degree of the denominator, then the limit of the function exists. Okay, so I'll take two different type of the problems where the degree of numerator is greater than the degree of denominator, but the limit of the function exists, or sometimes the limit of the function does not exist. Okay, okay, let us consider one problem here. The question is, okay, basically, there are two things. Even if the degree of numerator and denominator is same, even then the limit of the function does not exist. Okay, suppose we can consider limit xy approaches to 0, 0. I'm assuming the degree of numerator and denominator same. Okay, suppose I can consider x upon square root of x square plus y square. Here the degree of numerator is 1 and the degree of denominator, it is basically square root of x square plus y square. Square root means half the power of x square plus y square become its power is 1 only. Okay, and I told you when you have a factor x square plus y square, in that case preferably you can convert or transform your problem into polar form. Okay, so what can you do? Simply put x equal to r cos theta, y equal to r sin theta. So x square plus y square is equal to r square. So as xy approaches to 0, 0, so it implies that r approaches to 0. So if we use this particular transformations, then your limit converted into r tends to 0. What is x? This is r cos theta. And x square plus y square become r square, and square root of r square is r, because r is always positive. R is greater than or equal to 0, because r represents the radius of a circle. R represents the radius of a circle, and radius of a circle is always non-negative. Okay, so r and r get cancelled out. So what is the limit of the function? Cos theta. But what is theta? Here theta is arbitrary. Here theta is arbitrary. Hence, limit does not exist. Okay. So what do we realize here? If the degree of numerator and denominator function is same and it is 0, 0.0 form, then the limit of the function does not exist. Okay, now we are considering the case when the degree of numerator is greater than the degree of denominator, and we'll see that either in that case limit of the function exists or not, and what are the different rules for the same. Suppose I'm considering question is limit xy approaches to 0, 0, x cube plus y cube upon x square plus y square. X cube plus y cube upon x square plus y square. Okay, suppose we are considering this particular problem. Okay, so again, because we have a factor x square plus y square, so what can we do? Because now in this case, degree of numerator is greater than the degree of denominator, and x square plus y square. If we choose the neighborhood of a point 0, 0, we know that x square plus y square can never be 0. Okay, because whenever we are saying limiting point means x and y, they are simultaneously can never be equal to 0. It means that your denominator can never be equal to 0. Okay, so whenever we are saying that it approaches to 0, it means that this number is very close to this number. So it clearly shows that your denominator can never be equal to 0. So it means that your limit may exist. So in this case, when we we assume that the limit of the function exists. So in that case, the only way to prove that the limit of the function exists is to convert the problem into polar form. Like I already told you, the neighborhood of a point is a circle. Okay, so if the limit of the function exists, then this is the only way to prove the same. So I'm simply converting it into polar form: x equal to r cos theta, y equal to r sin theta. So it means that x square plus y square is equal to r square. So as xy approaches to 0, 0, it implies that r approaches to 0. So now this problem converted into limit r approaches to 0, x cube plus y cube become r cube cos cube theta plus r cube sin cube theta upon r square. Now this is equal to limit r tends to 0. So here r cube is common. We have cos cube theta plus sin cube theta upon r square. Now you can see here 2 power of r get cancelled out. So we left with limit, we left with limit r approaches to 0, r into cos cube theta plus sin cube theta. Now because r approaches to 0, and cos and sin, they are bounded function, because cos theta and sin theta, they are bounded function. Their maximum value is 1. So cos theta is maximum value is 1, sin theta is maximum value is 1. It means that their sum, cube sum, they have a maximum value 2 only. And if I multiply 2 with 0, then this number is approximately 0 only, because this is a very small number, approximately 0. So if I multiply any number with a very small number, then its value is again very small. So we can say that the limit of this function is 0. What does it mean? In this case, the limit of the function is 0. So here we have discussed the case where the limit of the function exists and is equal to 0. So what is the condition? The condition is the degree of the numerator is greater than the degree of the denominator. But the condition is the degree of denominator should containing even power with a positive sign. Even power with positive sign. Okay. What will happen if it doesn't have an even power, or if it has a negative sign? Let us see. Suppose I consider another example. We are considering the problem here. Question is limit xy approaches to 0, 0. Here I am considering x square plus y square upon x plus y. Okay, although I'm considering here positive sign, and here the degree of numerator is 2, degree of denominator is 1, and it is 0.04. The degree of numerator is 2, degree of denominator is 1. So clearly degree of numerator is greater than degree of the denominator. Now, but what will happen in this case? Because your denominator containing odd power means if I say x plus y, they can be 0, because x plus y, it simply represents the straight line which passes through origin. It gives us x equal to minus y. If I choose this particular line, this line containing the neighborhood of a point 0, 0, and here along this particular line, your function is not defined because your denominator is 0. So in this case, actually limit of the function does not exist. Okay. If I want to prove the same, what can we do? Again, we have a factor x square plus y square. So what can we do? We can convert it into polar form. So if we convert it into polar form, put x equal to r cos theta, y equal to r sin theta. So we can get x square plus y square is equal to r square. So as xy approaches to 0, 0, it implies that r approaches to 0. So we have limit xy approaches to 0, 0, x square plus y square upon x plus y. Now this is equal to limit r approaches to 0, r square upon r cos theta plus r sin theta. So this is limit r tends to 0, r square upon r cos theta plus sin theta. So this r and r get cancelled out. Now here r approaches to 0. Here r approaches to 0. But the problem is cos theta plus sin theta can be 0. Here, if I choose theta equal to, say, in the second quadrant, means I can choose theta equal to pi minus pi by 4, means 3 pi by 4. So cos 3 pi by 4 is minus 1 by root 2, and cos sine 3 pi by 4, its value is 1 by root 2, because in the second quadrant cos is negative but sine is positive. So in that case your denominator is 0. So it means that this is not a bounded function. Okay, because you know that although r approaches to 0, but if I multiply 0 with infinity, then it is not defined. We can't say that it is equal to 0. Okay, it is not equal to 0 if I multiply 0 with infinity. So it means that in this case, because cos theta plus sin theta can be equal to 0 when theta equal to 3 pi by 4, or we can say that when theta equal to minus pi by 4. So it means that this limit does not exist. Okay, so what do we find out here? That even if the degree of numerator is greater than the degree of the denominator, and if your denominator function having odd power, even in that case, the limit of the function does not exist. Okay. Okay, so already this video is of 1 hour. I think that is enough. So in the next video, I'll discuss the problem based on the continuity of the function. Okay, so just try to revise this topic, and you can also try some problem based on the limit of the function. If you find out any doubt, or if you have any specific uh, point related to this particular part, then you can write it in the comment section. Okay, thank you. Have a nice day.